All right, this is chapter 5, lesson 1. I don't have a title screen, but it is adding and subtracting to solve inequalities. So instead of equations, we're going to do inequalities. So the first one is just kind of a warm-up exercise to get you ready for what inequalities are. To remind you, write an inequality that describes the number of CDs you can buy for $12 each if you have no more than $60 to spend. Okay, in other words, if you have no more than 60, that means you don't have to spend exactly 60. Can you buy 6 CDs? We're going to use the inequality to answer that question, and then why or why not. So here's our answer. And just to remind you, this would be $12 times the number of CDs right here, that would be times the number of CDs you buy, has to be less than or equal to 60. We can spend all 60, we can't just spend more than 60. So the answer to the question, can we buy 6 CDs, is no. $12 times 6 CDs is less than or equal to 60. Let's see. Question mark. Okay, 12 times 6 is 72. 72 is not less than 60, so we could not buy 6 CDs. We don't have enough money. All right, so let's review what inequalities are. Just reviewing them, this means less than. We always read math problems left to right, so you always say what's on the left is less than what's on the right, because the small side always points to the lesser item. So as we read left to right, we would say A is less than B. So that's why this one then would be greater than, because again, reading left to right, we would say 8 is greater than 7. Number 3, this is less than or equal to. Again, pointing to that what's less than on the left. This adds the equal to. And the last one is obviously greater than or equal to. Okay, so there's those. How do we graph them? Because we do graph these. We graph these on a single line, not a coordinate plane, just a single number line. And here's how we graph them. On a number line, if less than or greater than, then we use an open dot. Okay, and I will show you what that means. So in other words, we're not including the point. So 8 is greater than 7, or if we had x is greater than 7, we would have an open dot. Okay? On a number line, if we have less than or equal to or greater than or equal to, then we would use a closed dot. So just keep that in mind. This determines whether the dot is closed. Okay? So here's an example. Graph the inequality x is less than 6.5. Okay? All right, so would we do a closed or open dot? Well, it's just less than, so we would do an open dot. Okay, which way will the line go? Well, we'd have to obviously make sure if x is less than 6.5, we would have to go in the direction of the numbers that are smaller than 6.5. So let's see. So 6.5 would be right in here between 6 and 7. So I'd make a line at 6.5. Make a better line than that. Make a line at 6.5. It's an open dot at 6.5, and I would shade my line then this way. In other words, all of these values on my shaded line would make this number sentence true. I could pick any value. -7 is less than 6.5. 0 is less than 6.5, and I would actually shade the whole thing, but I'm not going to. So there's example 1, just graphing. If it was less than or equal to, we would just close this dot. This graph shows that 6.5 is our boundary point, but it's not included in the solution. Okay, so example 2, write an inequality that's represented by this graph. So, since the dot is open and the line is going to the left, the inequality is written x is less than 8. So it's a good example. I mean, kind of similar to the last one. Open dot means 8 is not included because 8 is not less than 8. It's equal to. So that's why it's an open dot. All of these values are less than 8. All right, example 3, solving an inequality using addition. Okay, just like with equations, we are not going to draw a line down this though, but it's very, very similar to how we solve equations. We do the same ideas, okay? So we're going to write our original inequality. So if you have it on your paper, you can work from there or you can rewrite it. And the goal obviously is to get x by itself. And right now we have an x minus 5. So to get rid of that negative 5, we would add 5 to each side, just like with equations, because a negative 5 and a positive 5 add to 0. And our goal is to get this alone. So on the left side we have x. And on the right side we have negative 3.5 plus 5. So just like an equation, the only difference is instead of an equal sign, we have an inequality sign. So x is greater than 1.5. So how would we graph this? Well, we would do an open dot because 1.5 is not included in our solution set. And we would go to all numbers that are larger than 1.5. So make sure we're always going in the direction that's larger or greater than what it's saying. And if it's less than, make sure you're going to smaller. And you can always check by putting a number like that you shaded. So let's pick 3. 3 is greater than 1.5, and that's true. So it's always good to get in the habit of just checking. Okay. Here's the check. They're going to pick a number. I didn't realize. And they're going to actually substitute it in. Sorry. So we're going to pick 6, which is in our solution set. 6 minus 5 is 1, and 1 is greater than negative 3.5. That was my bad. You should always go back to the original inequality to check. You should absolutely do that, so I'm glad they did. That's what you should go back to and check to make sure you've graphed it correctly. Always go back to the original inequality. Okay? All right. Now we're going to be using subtraction. So obviously, here's our inequality. 9 is greater than or equal to x plus 7. So again, our goal is to get the x by itself. So the way we undo addition is by subtraction on both sides. So we're going to have subtraction on both sides. Positive 7, negative 7 add to 0, just like with equations. So we have x left on the right, and 9 minus 7 is 2 on the left. So x is less than or equal to 2. Now this time my x is on this side, so make sure you're paying attention. I'm reading this from right to left because I like my answer to say x is less than or equal to 2. That helps me know how to graph. I could read it this way: 2 is greater than or equal to x. But to help me graph, I'm always going to read with my variable first. And I could flip it if I wanted. X is less than or equal to 2. That might help me graph it. Notice the smaller side is still pointing to my x. If I flip this around, I have to flip my sign around too. Okay, so here's how we graph. It's a closed dot because we have the equals to line. So it's a closed dot. In other words, 2 should be included. And everything on here should be less than or smaller than 2 because x is less than or equal to 2. And we're going to check. Oh, nope, let's check it. Let's just pick a number and check it just to be safe. So let's pick 0. 0's on my thing, on my shaded part, and it's easy. So let's go back up here to our original inequality. 9 is greater than or equal to, let's put in 0 for x. 9 is greater than or equal to 7, and it checks. So I shaded correctly. All right, the last example. You are checking a bag at an airport. Bags can weigh no more than 50 pounds. Your bag weighs 16.8 pounds. Your bag, just your bag, with not anything in it. So find the possible weights in pounds that you can add. How much clothing, how much weight do you have to play with so that you don't exceed 50 pounds? Okay? So let's write a verbal model just to kind of think about it. Our weight of the bag plus the weight of clothes, shoes, makeup, girls, all that stuff has to be less than our weight limit. Okay? So the weight of my bag is 16.8. The weight of the clothes and stuff we're adding is W. It's our unknown. Everything needs to be less than the weight limit or equal to. We can go up to 50 pounds. No more than. So there's our inequality. So let's solve it. So 16.8 plus W. So obviously we're going to subtract 16.8 from each side positive 16.8 and negative 16.8 add to 0. And obviously the weight we can add to the bag is 16.8 pounds less than 50, or 33.2. So the weight we have to work with is less than or equal to 33.2 pounds. So that might determine whether you're going to take the really heavy boots or maybe the lighter weight shoes. All right, that's the end of the video. You can stop and please do the guided practice. Thank you.